In this lesson, we're going to learn about the law of cosines. When do we need to use the law of cosines? Well, you'll notice when you look at this formula, it's a little more complicated than the law of sines. So we like to use the law of sines as our first option, if possible. And if I can't use the law of sines, then I'm going to use the law of cosines. It really isn't as difficult as it looks. There's a lot of letters, but if you can find the pattern and how to use the law of cosines, you'll see that it's actually quite easy. So let's first look at when would we use the law of sines. So the law of sines we've already gone over. What cases of triangles do we use the law of sines? We have our angle, side, angle, our angle, angle, side, and then the last one that we learned that was the hardest was the side, side, angle, and you had to be careful with that one. Okay? So if we have those three cases, we'll use the law of sines. If we don't, we're going to use the law of cosines. What's important to remember about the law of cosines is basically the pattern. Like I said, if you can remember the pattern. So let's look at this first formula right here. It says that this a squared is going to equal b squared plus c squared minus 2bc cosine of a. And what you'll notice is that I have angle A here, and I'm trying to find angle side here. So that's going to be important to match those up. These other two sides, the B and C, are what's going to be squared and then multiplied by 2 and subtracted. So if you look at the second formula, we have the B squared here. So we're looking at the B squared here is going to equal this squared plus this squared minus 2 times this times the cosine of this. So you'll notice that I've paired up my angle B and my side B. Same thing is going to happen with my C's. If I look at the last formula, I have the C squared equals this squared plus this squared minus 2 times this, cosine this. So once again, I'm pairing up my C's. So I'm going to do a couple examples and it'll make a little bit more sense. Okay, here's an example. I need to solve this triangle. I'm given two sides and an angle. But when I draw this, and notice how I have B is 112 degrees, so I'm going to try to get as close as I can to 112 degrees. I don't have the side opposite of B, but I do have this side. I'll make this my smaller side of 16.2, so this is angle C, and this is my larger side, so that's going to be opposite the angle A. And you'll see that I have what we call side, angle, side. Okay, I have a side, and then I have the angle between it and another side. Okay, and this is going to be a case where you can use the law of cosines. So what my cosine is, if you look at it, I have angle B, and I can find side B first, using the law of cosines with the b squared, because that's the one I'm going to find. And once again, don't get caught up in the letters. What you want to do is look at the pattern. So I'm going to take my 16.2 squared plus 24.4 squared minus 2 times 16.2 times 24.4 cosine 112 degrees. Okay, and that'll equal b squared. I'm going to actually put this whole entire thing into my calculator as is. You can type it exactly the way I have it here, and we'll come up with what b squared equals. So when I put this into my calculator, I get 1,153.95. And that's what b squared is. So b is going to be the square root of that. And I get it to be 34 if we round it off. So my b equals about 34. Now I can use my law of sines. Since I have the angle B and side B, I can find my angle A or my side angle C using my law of sines, which is a little bit faster. So since I'm finding an angle, I'm going to put my angle on the top. And let's find sine angle A first. So I can do this into my calculator. I'm going to end up getting 24.4 sine of 112 degrees over 34 equals the sine of A. So on my calculator, I can put that in. So I get the sine of A equals 0.665, so A is going to give me 42 degrees if I round it to the nearest degree. So I have angle A, and then how do I find C? Once I know that this is 42 degrees, I can just use my C equals 180 minus the 112 plus 42. So I get 180 minus 154, and I end up getting 26 degrees. As we did at the law of sines, when we're solving a triangle, make sure you look at the answers, and you can see that my angle C is 26 degrees. So this is angle C. This should be my smallest angle. B is 112, so side B should be my largest side, and all of our answers look reasonable. Okay, now we're going to deal with the triangle that I'm giving you 3 sides. So this case is called the side, side, side triangle. And I can't use the law of sines because I do not have an angle to be part of my proportion. So I'm going to have to use the law of cosines on this one. There's one thing to watch out for on this, and it's not a hard thing to watch out, but you must solve for the largest angle first. And that way you'll avoid having to deal with the ambiguous case for the law of sines. So as long as you remember to solve for the largest side first, you should be fine on this one. I'm just going to set this up and try to get, this is 12, so this will be A. I'll make this 10, so this will be B, and this will be 7. Okay, so what am I going to do to solve this using the law of cosines? I want to find my largest angle first, so I'm going to find A first. So I'm going to use the law of cosines that has the cosine of A in it, which means I'm going to have 12 squared equals 7 squared plus 10 squared minus 2 times 7 times 10 cosine of A. My only unknown in this particular case is the cosine of A. I really don't know what angle A is, so I'm going to have to do a little simplifying, rearranging of this formula before I can find the cosine of A, and then I can put that into my calculator. Some people like to remember these formulas and they just write down the formula, and I can write the rearranged formula as well, but I'm going to have 12 squared minus 7 squared minus 10 squared, all divided by negative 2 times 7 times 10, and that's going to equal the cosine of A. So all I did was subtract the 7 squared from both sides, the 10 squared from both sides, and then I divided by the negative 2 times 7 times 10, so that I had the cosine of A by itself. And I can put this all into my calculator. As you can see, I put a photo of what I typed into my calculator, and so you can see where the parentheses are and how to type it into your calculator. I ended up getting the 0.0357 equals cosine of A. So A, notice how I type this in, is going to be the inverse cosine of what I came up with here. The best way to do it on the calculator is to put in the answer so that you don't have your rounded off version. And you'll end up getting angle A is about 88 degrees. Now that I have that angle A is 88 degrees, I can use my law of sines, and I can come up with angle B and angle C. Since I'm finding angles, once again, I'm going to put the angle on the top, and we'll find B first. And it doesn't really matter the order. I have sine of B equals 0.833 approximately. So B is going to be 56.4 degrees. Okay, and then once I have B is 56.4 degrees, my C can be the 180 minus 88 plus 56.4. So C will equal 35.6 degrees. Let's just recap when we can use the law of sines and when we can use the law of cosines. So this is one thing when you are told to solve a triangle, you're going to have to decide which one of the two laws I'm going to use. For the law of sines, remember we can use the angle, side, angle, 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 side, and our side, side, angle, and watch out for this one because you may have 0, 1, or 2 triangles. Okay? For the law of cosines, you're going to use the side angle side. So if I have side angle side, I can use my law of cosines, or side, side, side. And this one, remember to find the largest angle first. Okay, and if you can remember that, you shouldn't have any problem with either one of these laws.